We are solving by elimination today. Go ahead and put your name on here. And like I said a moment ago, elimination is your exit ramp from substitution part 2. You still need to be able to do substitution part 1. 3.5 is still an assignment that is worth points. But 3.5 on the test, you could always choose to do elimination. So if you were struggling with substitution, go into today with an open mind, because it's a completely different method of doing the same thing, and maybe you'll like this method better. Most people do. A system of equations is still a collection of 2 or more equations. And a solution to a system is still the point that makes both of our equations true. Okay. We have 6 steps again. Step 1 is like the beginning step, just like it is with substitution. And then steps 2 and 3 are different. Steps 4 and 5 and 6 are the same as substitution because it ends the same way. It just starts completely differently. So step 1 says multiply one or both equations so a variable will eliminate. Let's think about the word eliminate. What does eliminate mean? To remove something, like it's gone. We need to make our one of our variables be gone. So we're either going to eliminate all of our x's or eliminate all of our y's. So then we can solve for the remaining variable. So then the next step is to add the equations together, eliminating a variable, solve for the remaining variable. Once we get one variable, we plug it in and solve for the second one, just like we did in substitution, and then we still write our answer as an ordered pair. So the or both is crossed out because on today's notes and assignment, you only have to multiply one. Tomorrow's, Thursday's notes and assignment, you're going to have to multiply both. And then on this first one, you actually have to multiply none. So moving down to our first example, this one, we don't have to multiply anything. So this is how elimination works. We are going to take these 2 equations and we are just going to completely combine them together. Combine our x's, combine our y's, combine our constants. So we literally are going to just add straight down like a 3rd grade multiplication problem. 8x plus negative 2x is 6x. Yep. Okay. Negative 6y plus 6y. What happens there? 0. They cancel. It's 0. They eliminate. Those eliminate. Then 22 plus negative 10, or 22 minus 10, is 12. So that right there is the magic of elimination. Because now what can we solve for? X. So we just divide both sides by 6. And we get x equals 12 divided by 6 is 2. Okay. Any questions about what just happened? The beginning of that is easier than the beginning of substitution for most people. The next part, though, does take a little bit more work. I don't think it's harder. It's just a few more steps. And you definitely have to show your work on these steps because this is not work that you can do in your head that I can follow along in your head. So the next thing that we have to do, steps 4 and 5, is substitute your solution into either equation and solve for the second variable. So the issue is we do not have a y equals equation up here like we did at the end of substitution. So we can take either equation. I always take the first, but you can do either. I always just do the first. So I'm going to take that first equation, 8x minus 6y equals 22. I'm just going to rewrite it as is, double check my positives and negatives and all that jazz. Then I can plug in x equals 2. So when I plug in x equals 2, it's going to look like this. 8, instead of x, I'm plugging in 2. 8 times 2 minus 6y equals 22. And now I need to solve for y. It's going to be a few extra steps to solve for y. They're not hard. It's just a couple extra lines of work. So I can multiply 8 times 2 together, which is 16. So I've got 16 minus 6y equals 22. Subtract 16 from both sides. Negative 6y equals 22 minus 16 is 6. And I divide both sides by negative 6. And I get y equals negative 1. Zoom out a little bit. Oop, wrong way. So you can see the whole problem there. We could have plugged x equals 2 into the second equation and solved, and we would still get y equals negative 1. And then we write our answer as an ordered pair. X always comes first, so 2, negative 1. All right. Any questions right now? Okay. So this one was already set up to eliminate because the 6y is already just magically canceled. They have to be the same number. They have to be opposite signs to cancel. Because if I had 6y and 6y, that would be 12y. Okay? Next problem I've got 2x and 4x. I've got negative 3y and negative 6y. Are any of those things ready to cancel? No. So I can make them ready to cancel. Do I want to make my x's cancel? So do I want to make 2 cancel with 4? Or do I want to make negative 3 cancel with negative 6? They're equally easy. Pick one. 3 and 6. Awesome. So we always want to look at the number that's closer to 0. I don't want to say smaller because technically that's bigger because it's negative. So we're going to look at that negative 3y. We need to turn it into a positive 6y in order to cancel with this negative 6y. What do we need to multiply that negative 3 by to turn it into a positive 6? Negative 2. So we are going to take our top equation. We are going to multiply our entire top equation by negative 2. Do you have your pass? Do you have your pass? No. Okay. I will check with them. Sit down. We're recording and in the middle of notes. So sit down and continue with notes. All right. So we're going to take our entire top equation. We're going to multiply it by negative 2. Both sides. You can do whatever you want to an equation as long as you do it to both sides. So negative 2 times 2x is negative 4x. Negative 2 times negative 3y is positive 6y. And then 7 times negative 2 is negative 14. So we have multiplied our entire top equation by negative 2. Once you have changed an equation, I would cross it out, but I would cross it out lightly so that if you need to go back, you can. So don't cross it out, scribble it out so hard that you can't see what was there. Now we are adding together these two equations. What's 4x minus 4x? Those cancel out. What's negative 6y plus 6y? Those cancel out. What's left on the left side of my equation? Nothing. What is the mathematical number for nothing? 0. Okay. On the right side, what's 14 minus 14? 0. Okay. So this is one of our special cases. Does 0 equal 0? Yes. Is that true or false? True. So what is my answer here? Infinite solutions. So same thing is still true, that if all of your variables cancel out and you are left with a true statement, it's infinite solutions. So we were trying to make our y's cancel, but when we did, our x's canceled too. Okay. Travis, do you have a writing utensil? Okay, it's back there. Go get it so you can take notes with us, please. All right, next one we've got 4x plus 5y equals 40. 3x plus 5y equals 35. Is it going to be easier to make 3 and 4 cancel or 5 and 5? So 5 and 5, they're already the same number. We need to change one of them. What do we need to change about it? Make it negative. Do you guys want to multiply the top one or the bottom one by -1? Bottom one? I heard bottom. Bottom's going to leave us with less negatives at the end, so I'm going to do bottom. So we're going to multiply the bottom one by -1. So we're multiplying by -1 on both sides. So -1 times 3x is -3x. -1 times 5y is -5y. And 35 times -1 is -35. Okay. Then, so I don't confuse myself on what I am and am not adding together, I'm going to cancel out that, or I'm going to cross out that. Since I just replaced that. Or I just, like, changed it around. Now, we are adding together this equation and this equation. Any questions right now before I do that? Okay. 4x plus -3x. Otherwise known as 4 minus 3. What's that? 1x. I'm just going to write x. What happens to my y's? They eliminate. That's the whole point. 5y minus 5y. My y's have been eliminated. And then 40 minus 35? 5. So I've got x equals 5. And so I could have written 1x equals 5, but since I knew it was already x by itself, that's why I just didn't write it. All right, we still need to solve for y. So we go back, we take either of our original equations. So I always do the top one. You could do the second one. So 4x plus 5y equals 40. Where can I plug in that 5? For x, because it is x equals. So 4 times 5 plus 5y equals 40. So I'm plugging it in for x. Okay, 4 times 5 is 20, plus 5y equals 40. I can subtract 20 from both sides. I get 5y equals 20. That's 40 minus 20 is 20. And then we can divide both sides by 5. So we're going to get y equals 4. 20 divided by 5 is 4. Should zoom out enough that you can see my x. Okay, we always write our answer as an ordered pair. So my ordered pair here is 5, 4. Remember, x always goes first. So if you were to solve for y, you would want x to go first still. All right. Calculator, that's what I'm looking for. I want to show you guys. This is true for any of your systems. For the ones that you graphed, the ones that you did by substitution, the ones that you did by elimination. I just want to show you at some point that this is true. You can check your answers to all of these by plugging in x and y for x and y. So right here I've got 4x plus 5y. So instead of 4x, I'm going to do 4 times 5 plus 5y is going to be 5 times 4. I get 40. So that means that this is a solution to the first equation. Then I have to repeat for my second original equation. So 3x is going to be 3 times 5 plus 5y is going to be 5 times 4 equals 35. So you can always plug in both x and y to make sure it's a solution to both x and y in both equations. Okay, any questions right now? Okay, last one then. We've got 3x minus 4y equals 10. Negative 12x plus 3y equals negative 27. We need to either make our x's cancel out or our y's cancel out. Is it going to be easier to turn a 3 into a 12 or a 3 into a 4? 3 into a 12. What do we need to multiply by? 4. So we're multiplying our top equation by 4. So 4 times 3 is 12x. 4 times negative 4y is negative 12. Just kidding. Negative 16y. And 10 times 4 is 40. And then remember, you want things to be the opposite, so that's why I'm making it 12x, because the other one's already negative 12x. So I want to make them the same number, but opposites. Right, we can, I'm going to cross off my top equation, just so I know I'm not using it anymore. And now we can combine. So negative 12x plus 12x, what happens there? Cancel, eliminate. 3y minus 16y, or 3y plus negative 16y, gives me negative 13y. And then negative 27 plus 40, or 40 minus 27, is positive 13. Right, we will divide both sides by negative 13. We will get y equals 13 divided by negative 13 is negative 1. Okay. Any questions there right now? Just giving myself more workspace. Okay. What do we still need to solve for? X. We know that y is negative 1. This is the first one where we've solved for y first. Make sure, regardless of which one you solve for first, you plug it in the correct spot. So if you know what x equals, plug it in for an x. If you know what y equals, plug it in for a y. So I know what y equals. I'm going to take one of my original equations. I always do the top one, but you could do the bottom one. 3x minus 4y equals 10. So that's why I don't want to cross that out so much that I can't read it. And I am plugging in negative 1 for y. So 3x minus 4 times negative 1 equals 10. Negative 4 times negative 1 is negative 4 times negative 1, positive 4. So I've got 3x plus 4 equals 10. And then smooth sailing from there. Subtract 4. 3x equals 10 minus 4, which is 6. Divide by 3. I get x equals 6 divided by 3 is 2. Okay, and then at the end here, make sure when you write an ordered pair, x always goes first. So we solved for x second, but in an ordered pair, it goes first. So our answer here is 2, negative 1. Okay. Any questions about elimination right now? Okay. We have 30 minutes left, which was exactly my goal. I am going to go ahead and stop this video.